Hello and welcome back to Math in 5 Minutes with me, Ms. Wadzinski, where I break down math topics into simple, easy to understand explanations. Today's topic is the Pythagorean Theorem. We're going to do a little bit more advanced examples with Pythagorean Theorem. So let's begin with a quick reminder of what the Pythagorean Theorem is. So the Pythagorean Theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse of a right triangle, or a squared plus b squared equals c squared is how we usually talk about it. And it can only be used for right triangles. That's really important to know. And the other most important thing to know is that a and b must be the legs of the triangle. They must be the two shorter sides, so that c can only be the hypotenuse, which is the longer side. Let's go ahead and start with an example here. Okay, so our first example says to solve for x, right? And we have this large triangle divided into two smaller right triangles. And we want to solve for x, which is this whole side down there. Okay, so what I'm seeing is that I can't necessarily use Pythagorean theorem to solve for x right away because I don't know if that is a right angle right there. So we need to go in parts actually. So we're going to focus on either of these two smaller triangles to find the smaller parts of that bottom side. So for example here, we could call this one x1. That's the first part of the entire base or bottom side. And we could call this one x sub 2. And if we find those two values separately, then we can add those up to solve for the entire bottom side. So it's going to be a two-part problem, but that's pretty typical in class. So we start off, I'm going to start with x1. Okay, so we set up the Pythagorean theorem solving for x1. So we would have 12, this side squared, plus x1 squared, the two legs, equals 14 squared, the hypotenuse. Using our arithmetic here, we could go ahead and simplify that to 144 plus x sub 1 squared equals 196. And then just using inverse operations, we can go ahead and solve that equation. Subtract the 144 on both sides and get 52, and then take a square root to get 7.2. Sometimes we'll leave that as a radical, but because we're going to be doing more than one step here, it's easiest to write it as a decimal for this example. Okay, so now we have that this portion is 7.2. So we need to go ahead and find the other portion now. So we repeat that process with the larger triangle. So we would be solving for x2 using this equation right here. So we would do 12 squared, the first leg, plus x2 squared, the second leg, equals 29 squared, the hypotenuse. Then again, using arithmetic and inverse operations, we simplify to get 144 plus x2 squared equals 841. Subtract 144 from both sides to get x2 squared equals 697. And then take a square root on both sides to get 33.6. So I didn't write this step down, but of course, right here, we will be taking a square root to cancel out the squareds there. So now we have 33.6 for the second portion, which would mean that overall, our x would be equal to 7.2 plus 33.6, which would be equal to 40.8. Right, and there we have it. So that was a two-step problem where we had to use Pythagorean theorem correctly to solve for our missing variable or our missing side. So that is your review of some more advanced Pythagorean theorem problems. As always, happy learning.